This is activity 1, which is the bluest from lesson 14, 4 representations. And so you have these mixtures of paint. I'm going to call these cans of paint, although I label the graph blocks and they use blocks. But I'm going to look at them as cans of paint that are getting mixed together. And so if you have 1 can of yellow paint and 3 cans of blue paint compared to these other mixtures, which one of these mixtures is the bluest? And then in number 2, it says order them from the least blue to the bluest mixtures. And so the reason I want to look at them as cans of paint that are getting mixed together is it's the same idea as when we worked with peanuts and raisins in a recipe, or lemonade and lemons and sugar in recipes. So we're going to mix these things together, and each time you mix some cans of paint of different colors together, that forms a proportional relationship. And so there are actually 5 different proportional relationships in this problem, 5 different recipes, 5 different mixtures. And so I graphed each of those onto this grid, this coordinate plane. And so I made the blue cans, and I'm going to call these cans, I made the blue cans the independent variables. I'm going to choose the number of blue cans of paint I want to use first. So for example, if I choose 3 blue cans of paint, then I'm going to use 1 yellow can of paint for this recipe, or I'm going to use 2 yellow cans of paint for this recipe. So notice that the yellow cans of paint, that is the dependent variable. It is dependent on the number of blue cans of paint I choose. So if I choose to use 4 blue cans of paint, then I can use 2 cans of yellow, or if I want to make this recipe, I can use 3 cans of yellow. So again, the blue cans of paint is the independent variable. It's what I'm choosing first, and the yellow cans are the dependent variable. So to figure out which of these are the bluest, I wanted to look at the constant of proportionality of that proportional relationship. Now clearly this is some kind of order. As it's more and more slanted, it's either getting more and more yellow, less and less blue, or it's getting more and more blue, less and less yellow. I don't really quite yet know which. And so I put this table together which arranges these recipes in this order from A, D, C, B, E, A, D, C, B, E. And so I wrote out the constant proportionality for each one. So for A, for example, I'm going to use 1 can of yellow paint for every 3 cans of blue paint. So I have 3 cans of blue paint, I use 1 can of yellow paint. So that constant proportionality, that ratio is 1 to 3. 1/3, so if you, and then the other thing I did in this case is I changed all of these constants of proportionalities to decimal values. So then I could look at just that decimal value compared to 1 can of blue paint. So this is 1/3 can of yellow paint for every 1 can of blue paint. That's what this 33/100ths means. So 1/3 of a can, or 33/100ths of a can of yellow paint per 1 can of blue paint. So for D, for example, if I choose 5 cans of blue paint, then I'm going to choose 2. I have to use 2 cans of yellow paint for this recipe. So that's 2 cans of yellow for every 5 cans of blue. That decimal value is 40/100ths. For C, it's half. 2 cans of yellow for every 4 cans of blue. So that decimal value is 50/100ths. B, it's 2 cans of yellow for every 3 cans of blue. So this is 2/3 cans of yellow for a single can of blue paint. And for E, 3 cans of yellow for every 4 cans of blue. So this is 3/4 cans of yellow paint for every can of blue paint. So what's getting more and more blue? I wanted to add one more point to this. What if I choose all blue? So down here along the x axis, this is all blue paint and 0 yellow paint. So if I include that in the table, that gives me a much better idea of what's going on. So I can use any number of cans of blue paint I want. I'm going to use 0 cans of yellow paint. That means the whole recipe, the whole mixture is just blue. So that's 0 cans of yellow paint for any number of cans of blue paint. So that ratio, that constant proportionality is 0. So 0, and it makes sense. 0 cans of yellow paint for 1 can of blue paint. So as you go in this direction, as you go from E to A and then finally to X, this is getting more and more blue. So you're moving towards using all blue paint. And that makes sense also. As you look at this ratio down here, this is 3/4 of a can of yellow paint for 1 can of blue paint. This is only a half a can of yellow paint for 1 can of blue paint. So it makes sense. As you go in this direction, the recipe is getting more and more blue. So as you go in this direction, so as this is getting less and less slanted, it's getting more and more blue as you move towards the x-axis. This is where it's all blue. And finally, the decimal value tells you the fraction of yellow cans of paint, blocks of paint, per 1 can of blue paint. So that decimal value is convenient in that it tells you how much yellow paint you're using for 1 unit or 1 can or 1 block of blue paint. Now I wanted to focus in on just a single recipe just to highlight a few other things, and I chose B here. So if you look at B, I'm going to write the equation for B. The constant proportionality is 2/3. So the amount of yellow paint equals 2/3 the amount of blue paint. So if you look at the number of units of yellow paint, which are 2 units, 1 unit, 2 units, that number of units is 2/3 the amount of blue paint. So the blue paint is 1 unit, 2 units, 3 units. So it's these 3 units, these 3 cans or 3 blocks, and the yellow paint is 2/3 of that amount. This is 1/3, 2/3. So yellow paint is equal to 2/3 the amount of blue paint. And if you decide, so over here, if the x value is 3, so the x value is 3, the y value is 2. So if you decide, rather than using 3 cans of blue paint, what if he used 1/3 as many cans? In other words, what if he used 1 can of blue paint? So that is right here. So at 1 can of blue paint, the yellow paint is 1/3 of 2. Well, 1/3 of 2 is 2/3. So this point right here is 1 for the blue paint, 2/3 for the yellow paint. So right here, that's 2/3 the length of 1. So 1/3 of 2 is 2/3. If you look at it as 2/3, 4/3, 6/3, 6/3 is 2. 1/3 is the 2/3. 1/3 of that 2 is that 2/3. And the last way I want to look at this is to use one of these diagrams. I'm going to start calling reciprocal diagrams because it shows the reciprocal nature of the constant proportionality. In one case, and remember, you always get 2 graphs, you get 2 equations. So here are the 2 equations. The amount of yellow paint is equal to 2/3 the amount of blue paint. That's what we just looked at. Or the same relationship, but the yellow paint is now the independent variable. You're going to choose the amount of yellow paint. How much blue paint are you going to use? You're going to use 3/2 the amount of yellow paint. So it's going to be the same mixture in the end. You're just looking at it from a reciprocal or the opposite relationship. All right, to make this diagram, I'm going to start with the constant proportionality that's greater than 1. That's this one right here. So the amount of blue paint is equal to 3/2 each can of yellow paint, or the amount of yellow paint. So that means the yellow paint is going to be 1 can. So I'm going to go around the circle. I'm going to label 1 time around the circle as 1 yellow can of paint. That is 3/3, by the way. All right. So the blue paint, I have to divide this into 3 parts. How do I know I have to divide it into 3 parts? that 3 right there. I want 3 parts. I want to get 3 halves or 3 parts. And also this part right here says I want thirds. So I want 1/3, 2/3, 3/3, or that's of blue paint, or 3 halves of yellow paint. So 1 half, 2 halves, this is the amount of blue paint, and 3 halves. So you go around, so this is 1/2 can of blue paint. That, by the way, is 1/3 can of yellow paint. And then when you get to finally 1 can of blue paint, so this is 2 halves cans of blue paint, or 1 whole can of blue paint, that is 2/3 cans of yellow paint. That's this equation right here. So the amount of yellow paint is 2/3 the amount of blue paint. So the amount of yellow paint right here is 2/3 each can of blue paint. And so then you keep on going. So how much blue paint do you use for a can of yellow paint? You use 3 halves cans of blue paint. So one more time, this is 1/2 can of blue paint, 2 halves cans of blue paint, or a whole can. That's equal to 2/3 cans of yellow paint. So it's 2/3 cans of yellow paint per 1 can of blue paint, or 3 halves cans of blue paint for 1 can of yellow paint. A reciprocal relationship. 3 halves and 2/3. 3 halves and 2/3.